And thank you to everyone for joining us today. As Tiffany mentioned, my name is Adam Groves. I work out of Virginia here for PTV in the US. And today we're going to talk about our cloud-based traffic management solution, PTV Flows. So some of you may be familiar with PTV or maybe not, but I think it's a good time to bring up, given the topic of today's conversation, that PTV over the last couple of years has joined forces with our colleagues over at Econolite under the Umivity brand. And first of all, it's really exciting in general, but especially in the context of today's conversation, where we're going to talk about some exciting integrations. This is a really exciting. So I wanted to give you just a little bit of background in terms of that. Across our product portfolios between PTV and Econolite, we cover kind of the full range of transportation solutions from modeling and planning, so everything from long-range transportation plans put together by MPOs and state DOTs, all the way through to operational, as well as management prediction. And you can see that we have a good overlap here in terms of our products. And today we're primarily talking about Flows, which also has some integrations available with Econolite Centrex. So for the flow of today's presentation, we're going to kind of break it down into 4 pieces. The first piece is going to be an overview of flows. The next, we're going to walk through some use cases where we feel flows can perform really strongly. Then we're going to jump on over into flows and actually show you give you a live demo in terms of how it works, how you operate the platform. And then finally, we're going to actually dive in and show you some really cool applications of the API that's available with flows and how you can use the data coming out of the system in some pretty cool ways. So the first part, let's give you just a quick overview. So Flows is a turnkey cloud-based traffic monitoring and prediction software that operates entirely off of floating car data. It has built-in automated maps that update periodically. We also integrate a machine learning-based traffic prediction. We offer custom alerting, and all this is available within a really easy-to-use web browser user interface. So we think Flows is really uniquely suited to solving a number of traffic management problems. One of the reasons is it can be deployed very quickly because this is a completely turnkey cloud-based system. It's basically as simple as, if on the screen there, you can see kind of a dotted polygon, drawing that polygon pretty much anywhere in the world, and we can begin to quickly collect data. So this eliminates the need to deploy hardware. This allows you to do things like cross agency boundaries onto roadways that maybe you don't manage, even across city, state, and country boundaries. We can give you real-time and predicted speed and travel time information as well as historical. We can quickly generate automated alerts, and we can utilize the API to supercharge your existing systems. So the first kind of input into this is the data side. So Flows comes with all the data you need to use the system, and we've partnered with industry-leading partner TomTom to provide floating car data. This is really eliminates the need for you to have multiple contracts with multiple vendors, do integrations, all those sorts of things. It's just all this is built into a single platform that you can access through the web browser. Now, one of the reasons we chose to work with TomTom is they really do have world-class and industry-leading data. One of the examples that we can reference to that is the Eastern Transportation Coalition did a number of studies across the country where they collected directly collected data, as long as look at data from major floating car data providers. And across the locations that they looked at, TomTom was really the leader in terms of being able to fully capture what they would term as slowdown events. So they took a look, and anytime there was a slowdown while they're collecting data, the data vendors fully captured that in terms of both the time of the slowdown and the speed drop during the slowdown. And this is where TomTom's data really shined and was able to fully capture this information much better than the other data providers. So this is one of the reasons we've chose to partner with them. Also, they have a really great worldwide presence, so it allows us to quickly deploy these systems in so many places around the globe. So once we have the system up and running, you can quickly kind of generate travel time segments to begin monitoring, and we're going to walk through as we go through the actual setup in the software itself. You'll see how we can set up alerts that can go out via email. These can be based on either the free flow travel speed or unusual conditions, as well as both the current conditions and forecasted conditions. So you can use those email alerts as well as the user interface to be alerted whenever slowdowns on particular roadways occur. You can also further extend that by using things like Power Automate from Microsoft to trigger additional actions out of that. So we'll take a look at more in-depth monitoring as we get into the software. The other big piece is the prediction. So we have a machine learning forecast, which allows you to view traffic conditions, predicted traffic conditions for up to an hour in advance. So as the system sits there, it learns and collects data. It's going to be able to accurately predict traffic in the near term. And using that, we begin to do some really cool stuff we'll talk about. It also gives you the ability to act directly. So we're going to talk here in a minute about our integration with Centrax Mobility. So by pushing this information out into other systems, we can begin to proactively manage traffic. We also have the option of including historical data as well. So as the system runs and collects data, you can go back and pull reports, download data, even do some really cool like time-lapse instant replay type things, as well as view different kinds of charts. So not only are we able to use this as a tool to actively manage traffic, but also to then go back and view historical data, learn from the past, and learn how we can better manage traffic in the future. So before we jump into the software now, we're going to talk about a couple of different use cases here that I think are good to keep in mind in terms of some kind of interesting ways you can utilize the software outside of just general traffic management. The first is that integration with Centrax Mobility. So Centrax Mobility is a kind of like cloud-based ATMS system. We've developed a direct integration with that with PTV Flows. What basically this allows you to do is set up a travel time segment in Flows. That information can then be viewed from within Centrax Mobility, as you see there at kind of the bottom in the map view. So you do get to see your ATMS system data as well as Flows data directly side by side. But the more exciting piece is the traffic proactive. And what this allows you to do is set up a rules-based system where you can look at either the current or predicted travel time around a corridor and begin to actively implement new signal timings based on that information. So I think a really good way to visualize this is if maybe you have an interstate as well as a parallel arterial corridor. So you could monitor the travel times on the interstate and begin to affect the signal timings on the arterials based on your expectation that maybe there's a slowdown in the interstate, so more users are going to transfer over to the arterial. You could do things like flush plans, a number of different options, but all this is totally turnkey, so there's no additional integration effort, anything like that. It's really a simple matter of tying the two systems together through an API key that's already pre-built, and you can begin implementing this really quickly. One of the really exciting things about this to me is that, seen kind of maybe some similar type stuff of this in the past, but they're typically very large, very expensive projects. And this really takes all those capabilities and puts them into a nice turnkey system so that really any agency, no matter what their size or what their budget is, can take advantage of this type of opportunity, as well as industry leading big data sources and machine learning. Another great use case for this is enhancing your typical PTV modeling workflows. So there's a few things that we can highlight here in terms of doing signal timing projects. You can collect before, during, and after. Travel time studies for your simulation projects. And when we get to the end here, we're actually going to show some of that directly within some of our software. Also, things like network speed profiles that you can pull down for calibration purposes for simulation or modeling projects. Another great use case is construction monitoring. Construction projects are pretty dynamic, so they are kind of finite in terms of how long they're going to last, but oftentimes you have shifting, may shift along a roadway as they're doing a progressive project. So Flows are really great because it is flexible. You don't have to deploy hardware that's for a temporary project, so we can quickly deploy the system, keep it running for the duration that you need it, set up your travel time segments, not only on the area that the construction is, but any alternate paths that may be affected by this as well. Its ability to quickly deploy and be very flexible and changeable is really great for construction projects. You could also use this to monitor speeds if you're concerned about speeding in the construction zone as well. Another possible use case is tolling applications where you may need to monitor the toll facility, but also any alternative paths. So you get a good idea of what the competitive nature of the toll road is and how much time is being saved by using the toll facilities. So it could be used for marketing purposes, for actually setting things like dynamic toll pricing, all those sorts of things. Again, just to be able to pull that information directly is really great for a tolling application. I think just, similar to what we talked about with Centrax Mobility, any of these kinds of like ICM or ITS applications, we've done all the hard work about integrating the data sources, user interface, the API. So it makes it much easier for you now to trigger things like RAM metering, any kind of integrated corridor management applications or arterial management to use big data and machine learning. Another great use case is multi-jurisdiction monitoring. So our traffic networks typically don't operate in a vacuum. It's pretty rare that you have one agency is responsible totally for a particular geographic area. So here in the United States, for example, you may have an interstate that's run by a state DOT going through a city. So oftentimes you may not have great information about other roadways that affect roadways that you manage. So Flows kind of solves this problem really easily. You don't need to coordinate or tie into any outside systems. You can work with Flows, draw the map to cover the areas you need to cover, and begin collecting data on roadways where you don't have, maybe the permission or the budget to deploy detection. So you can begin to collect real-time data for all those kind of external roadways that manage or affect your roadways. It's also great for applications if you think about an agency like an NPO who kind of is inherently multi-jurisdiction and have different members, and you need to monitor the entire area holistically. This is a great application for Flows. Another one is special events, again, because special events are just, kind of special, right? They're temporary, so it may not justify deploying more complex systems, physical systems out there that you're not going to maintain over the long haul. So if you do have a special event going on, it's very easy to deploy Flows in a really rapid amount of time. I always tell people it probably takes in total about an hour to deploy one of these systems. In practice, it may take a little longer, but we're able to quickly deploy these. If you need a new system, but maybe you have an existing system and you just need to start monitoring different roadways, again, really easy for you to do. So we think special events are really a great application for this technology as well. All right, so with that, I think it's time for us to go ahead and jump into the actual software here. So let me pull up a copy of Flows. All right, so this is the Flows user interface. This is currently using Chrome directly in your web browser. So this is how you interact with the system. So we do have a ptvgroup.tech webpage, and from here you can log in. You see my initials up here in the top right, and this is where you will access one or more Flows systems, as well as our other software like Lines or Hub. So this is kind of your single sign-on for all things PTV related. So you can have multiple Flows instances here as well. So maybe you're a consultant and you're dealing with multiple agencies. They're able to invite you in and you'd be able to see this data. So once you log in, we're going to have to jump right to the most exciting part, which is the supervisor. So this is the main view through which you interact with Flows. This happens to be in Portland, Oregon. So I'll zoom out here so you can see. And then I'm going to just hide a couple of things here so I can kind of walk you through. So as I kind of mentioned earlier, you can see this dotted line here. This is how we define the Flows system. So we go into a configuration tool and we draw this polygon, and that's going to tell us where we want to begin collecting information. You can also choose which functional classes of roadway you want to collect data on. And just to give you an idea in terms of how the systems are scaled or priced, it's based on the total number of directional roadway kilometers or miles. So we can really narrow down to exactly the specifications that you need. We can do multiple polygons, so you can monitor different areas, as well as change those levels of detail in terms of functional classification. From there, that highlights all the roadways we've selected. So this is that speed profile view. So this is showing you the current speeds for that network. So you can see some of the roadways based on the functional classes we chose don't show up here. You can hover over any of these and it's going to give you the current speed on the network. So I can select here, and on US 26, it's currently 21 miles an hour. So the next piece of the puzzle on top of this are KPIs. So KPIs are basically the travel time segments. So if I hide the background traffic here, I can swap over and select the KPIs. So these are the travel time segments we've drawn for this particular area. They're colored based on where they fall in their alerts that you set up. So there's normal, warning, critical, or no value if for some reason there's not enough data there to produce a good value. And over here on the left, we can see our alerts, which show us which of those KPIs are in those various statuses. So I can select this, and we can see if I want to see which one of these is critical, I can hit that, and it's going to highlight that on the map for me. We can toggle through, then see which ones are in warning and which ones are normal. And you can filter these, highlight them on the map, or you can kind of snooze the alerts. If you know one of these is going to be congested for some reason, other say construction project, you could do that. So you can view that together. Overlay as well. If we dive into one of the KPIs here, I can show you how these are, the alerts are defined. So you can give each location a name, so that's the roadway. Then you can, all the alerts are based on travel time currently. Then you have the option of your trigger type. And there's two options, which currently are free flow and unusual. So free flow is the free flow speed. So basically, if you were traveling the speed limit. The unusual is based on the 95th percentile travel time on that segment as Flows has collected it. So the 95th percentiles, as well as the averages, are calculated on an hour of the day per day of the week basis. So every day during the week, so every hour of the week basically has its own unique average and unusual travel time. From here, we can set parameters about the alerts. The first is the departure time offset. So this is basically, are we going to use the real time or a predicted travel time? So this, if we set this as 0, this will use the current travel time of this KPI. If you were to set 10 minutes, it would be based on the prediction 10 minutes in the future. Then we can set the thresholds for warnings and critical. In this case, it's free flow. So at this point, it will generate a warning when it's 140%. The current travel time is 140% of the free flow travel time, and critical at 180%. Now, if I toggle over to another that's set up based on the unusual travel time, you can see the warning threshold in this case would be 9% of the 95th percentile travel time, and the critical would be at 100% of the 95th percentile travel time. And then here you can set to trigger the alert. You can choose the email and which triggers you want in terms of that. We're not going to set up any of those right now, so I don't start to get emails every time this happens. Now, once you've selected one of these KPIs, you can go in and look at some additional information. So if we click the charts button here, I'm going to ignore the changes. This is going to bring up some information on this particular KPI. So up at the top, you have the current, average, free flow, basically the delta from free flow, and the unusual travel times. And below here, we'll see a chart that will give you information about the last 24 hours. You also get this kind of heat map of this segment over the last 24 hours. If we go back to the map, let's choose maybe one that's probably a little more, seeing some a little more congestion. So yeah, we can see that, yesterday afternoon, during the PM peak travel time, what the disruption was. Now, if we do want to look at the predicted speeds rather than the current speeds, go up here to the top, and you have this kind of crystal ball, and we can select, instead of the current travel time, we can select the future. So if we said 30 minutes in the future, we'll see the map update with the forecasted information. We could change that then to 40 minutes or 60 minutes, and we can see the network change based on that information. One thing I do want to highlight here, and we talked a little bit about tolling applications earlier, I'm going to switch over to another instance of Flows, which is in Northern Virginia. So this is kind of representing major commuter corridors here in kind of the Northern Virginia area. So I do want to highlight, if we zoom in on 66, for example, and I turn off the KPIs just to make it clear. So in a lot of places here, like on I-66, there are express lanes. Also, we can toggle over to the Capital Beltway. And you will see we are getting different speeds for the express versus the general purpose travel lanes. So if I click on here, we can see that we're going 73 on, I believe that is the, that'll be the express toll / HOV lanes, and then general purpose lanes are traveling at 63 miles an hour. So we can actually detect that. In this case, these roadways, I know the Beltway, and I think 66 too, they're not totally separated roadways. It just has kind of the plastic dividers that you could drive over. Same thing going over here to the Beltway, where there's express lanes, and you can see that we are collecting 73 on here and 61 on this segment. So we are getting separate data feeds for the general purpose and the toll lanes. So just wanted to highlight that we do have some really detailed data, and this seems to be from a number of places we've looked, kind of unique to TomTom, that we're able to get that information from those separate facilities. Going back into our Portland example, we've kind of looked at the supervisor here, but I'm going to switch over and let's take a little bit of a look at some of the historical data options that are available to you. So there are a couple. So the first is the historical KPIs. So this is what's going to enable you to pull historical data for any of those travel time segments you define. So as you'd expect, we have the option here to choose what KPI we want to look at. If I click it, it'll highlight it on the map. So you can toggle between different ones. Up here, we can choose date range. So in this case, maybe we want to look at the last work week. So let's actually go back a little bit, since that was Labor Day. So that's a little bit of an unusual circumstance. So we'll go from August 25th to August 29th. And if we hit load data, it's going to go fetch that data. It's going to give us this chart here that'll let you know what proportion of the time during the time you selected that the KPI was in a normal, warning, or critical status. And it's also going to give us information about on the chart there. So if we zoom in, we can look at some times in more detail. You do actually then also have the ability to go in here and download the KPI values or the KPI details. The difference there, the KPI values will give you the overall travel time for this segment. The details will give you each individual underlying map link details as well. So just depending on what you need, and you can download that information to use. You also have some controls here in terms of scaling, panning, zooming, and be able to download any of these as a plot as well. I can go and select another one now and load the same date range. And you can get an idea in terms of what that may look like on another travel time segment. I can also click here and toggle off the unusual value, which again is the 95th percentile, and the average if I want just look at the actual values. So let's actually kind of use this to demonstrate the next feature, which is the historical replay. So on August 27th here, we see there's a pretty good spike in the values right around, let's see, right around 8 o'clock. So August 27th at 8 o'clock. Let me go back and let's take a look at the historical replay. So what this gives you is kind of an hour's worth of a time-lapse view. At this point, it's only for the KPIs. So if I go back to the 27th, and let's select 20, I have to do that. 8 p.m., hit load data, and it'll start to actually do a replay, hit play. It'll actually walk that through, and it seems like in this case, it was pretty congested for most of the time, so maybe there was some construction going on or something like that. I want to look a little bit further, maybe I could do like 7:30 instead, so try to catch the beginning of the slowdown. Well, it's pretty well congested for most of the time, it looks like. So we can kind of keep stepping back in terms of time till we find a period of time that it looks congested or uncongested so we can see it developing. Let's go way back here. It's pretty congested that whole day, so interesting. But you can see that, you know, if this was something where you came in from a weekend, had a bunch of complaints, or, you know, there was some event after hours, this is something you can actually go then and pull at a later date to kind of get an overview of how all the, you know, KPIs interact with each other and what may have happened during that time. This is also available as a download as well, so if you need to pull this information. We can also go here and pull information about one of the specific KPIs as well and download that information, or we can click on this Analyze KPI, and that's going to open a separate tab that's going to shoot us over into that historical data for that particular time. So this is a really exciting feature. Like, you know, hopefully in the near term, we'll see some more cool applications of this, including, you know, having all the background traffic, maybe some kind of automatic, you know, video production or something that would, you know, send you an email that would have a replay of a bad event that happened overnight or over the weekend that you may not have been, you know, around to see. So just to touch on a couple of other items before we move on to some of the API applications. You do have the ability to manage users. It's really simple in this. So it's all username and password based. So basically you can go in here. If I want to invite an additional user, I could hit add their email address, select what roles I want to give them. Right now, you have the options of administrator or operators. And that will, and hit send an invitation. It'll send an invitation by email, and you'll get an alert here, you know, that, hey, this is pending their acceptance, or, you know, this is waiting, or there's option to remind them, things like that. You can see any of the current users who have access to the system. So API keys is where you can go to manage your additional API keys that would connect to things like Centrax Mobility or some of the applications we're going to discuss here in just a moment. Instance configurator is how you set up the system, how you can adjust those boundaries, how you can set up things like your time zone, you know, basic information like that, do map refreshes. So no need to dive too much into that, but that's basically how you configure that. You also have the option to get support or to take a look at the help, which I'll click over to here. So this will give you web-based help, so you can see in terms of things like KPI management, details. So give you information, any kind of details you may want in terms of how the system operates, you can find here. One thing I haven't showed so far is how you go about drawing the KPIs. So let's do that real quick. So let's say if we take a look and we want to begin collecting information around Route 29 here. So how do you draw those KPIs? It's super simple. Click on the pencil here, and we're going to call this Route 29, and we'll call this eastbound. Then I can click the draw button, and let's say I want to start from this intersection here. Then I can basically click intermediate points along the way. Let's just do this, although it's worth noting, if you do, this does have routing underneath, so if you need to do this around corners or something like that, you certainly can. But in this case, we're going to just end it right here, kind of this intersection. Let me zoom in so I get exactly what I want, double click. Gives me option to accept that, so I'm going to click accept. I'm going to set this up based on the travel time. We're going to do unusual circumstances. Let me give it a name here, so we'll just say Route 29 eastbound. We're not going to use departure time offset because we want this to be a real-time alert rather than a prediction alert. So we're just going to leave these the same and hit save. And we get a note here that this was saved, and it's going to be this kind of white color here, letting you know that it takes a minute basically before we'll collect it. And probably by the time we're done here, we should have some data flowing. I'm just going to real quick then actually do the opposite. So we'll do Route 29 westbound, draw, go down here, select my start point. Accept, and we'll just keep all this information default, except for I'm going to change the name here. So you do have the option to, you see there's a location name and a name. So you can have multiple alerts set up based on the same path, basically. So that's why there's the difference there. In this case, we're just going to kind of keep it this one-to-one relationship. So I'll hit save. And that appears. And here in a few minutes, by the time we are done the webinar, we should have data collected there. So that's how simple it is to set up these travel time segments. And, by the same token, if you want to delete one, you could easily delete one, no problem. If we did want to create another one, so let's not do that. Yeah, so super simple to draw these KPIs. So with that, we're going to actually switch over now and talk a little bit about the APIs, because this system is really great, and you can do a lot from within the system, but there is a lot of reasons why you may want to pull additional data from the API or some information that's not built directly into the system. So one of the examples of that we get asked about, somewhat frequently, is the ability to calculate the various travel time reliability metrics. So let me jump over and show you how I can go about doing that. So in order to demonstrate, just go back to the web, in order to kind of give you a good starting point, if you do want to play with the API, we have put a number of examples up on GitHub that are available for you free to download and play with. They do require an API key in order to work. So unless you have flows, you're not going to be able to actually use them. But if you do have flows, this is a way you can get on and actually try some stuff out and kind of, steal some inspiration. So we have a couple different options for ways to pull data. One is directly from within vZoom, which we're going to show today as well. Also, we have the ability to do Power BI, Excel, which I'm going to talk about here in a second, Postman, and then Python. So we want to give you a really good starting point for how these things work. So in this case, if I click on the vZoom integration here, we have a version file that we're going to take a look at, some Python scripts, and a description of how to use it. Same goes for Excel. You'll be able to download the Excel template as well as the scripts needed, and there's some instructions on how that will work. So if you download this and you have an API key, we can jump in and show you how that works. This works really simple. So right here, there's a box where you put your API key. I have mine in there. I just have the text is white there, so you can't see it. So from there, there's a pretty good description. There's a README. Clear these logs here. So the first thing we can do is go out to a particular Flows instance and get all the KPIs. So if I toggle back to Flows here, to supervisor. So we're going to be using for both of these examples the Portland version here. So I'll pull this up just so you can see it. So if I hit the get KPI definitions, what that's going to do is go out to the the API and actually pull all the information for all the travel time segments we've defined here. So it'll give you the names for the KPIs, the location names, and some miscellaneous information. Creates a link there so you can go to it. Also tells you how long they are. But maybe you want to get some additional details about one of those KPIs. So what I can do is select the KPI name here and paste it up into this column. Then I can set up for when I want to get the data. In this case, we've got August 4th during the day. And if I hit get detailed results, it's going to create this additional sheet here. And it went out and got all the information for that particular time period. So it's going to give me the value, which is the actual data, the 95th percentile or unusual value, the average value, and the actual speed, as well as the OpenLR code for that particular travel time segment. For the detailed information, you can also choose your travel time aggregation. So I'm going to say 15 minutes. And there is some for the time, there is some formatting for transferring the local time of the system with UTC time. So now if we want to get even more detailed results, I can hit the overall results. That's going to generate this other sheet. And that's going to give me my 15-minute bucket. So if you look at the time here, we've got 7 a.m., 7:15, 7:30, 7:45, and give me the value, unusual, and what the status is. In this case, because I think this was one that we had recently created, the average isn't calculating yet. So if I go back and let me swap that, clean that, and do let's do 264 eastbound. And if I get the results there, then we'll have values for all these. So you see, yeah. So you have all those various aggregations. We can get even more information. So if we hit the get percentiles and indexes, we're going to see a whole bunch of other tabs come up down here. So if I hit that, we can walk through some of these. So the time I chose kind of went from Monday into Tuesday. So it'll give you the average values across all those hours of the day. Percentiles, so this will give you per hour of the day, the percentiles. So if I were to filter this, say we want the 95th percentiles across all those hours, that's going to give us that there. You also have some different percentile pivot table examples. And then indexes, and this is where we show how you can calculate the travel time index, buffer index, and planning time index for travel time reliability. So that information is there as well. This does, the unique thing this has that this is not currently in the user interface piece as well, is the ability to pull historical data before you set up one of the KPIs, so you're able to do that. We can also generate the heat maps for just like this in the web interface. So if I click that, maybe. Choose one of these other, might be a time issue. Well, of course, there we go. It took a minute. So this will give you, if I zoom out, that same kind of heat map, but now you have it in Excel across that time period, and you can use this, however you would like. So that's kind of an overview there, and then there's a button here that you can just clean everything up and go back to the beginning. So super easy way, demonstration, all the scripture there for you to kind of demonstrate, how to pull this information out of Flows into Excel or some other software for you to use. On the vZoom side, that's also quite interesting because this kind of demonstrates how you can use this to kind of automate pulling some of that data for calibration, for instance. So this is a vZoom network for the Portland area, kind of the same coverage area that we were looking at Flows in the web interface. And so ways to set up now, we have a script, so I can actually just drag and drop a script. So the first one I'm going to do is going to basically take the information from Flows. It's going to go out, get all the KPI definitions, and then match them into the Zoom network, so we have them there to use as travel time segments. So you can think of this, maybe within Flows, you have like critical travel times that you're monitoring. You want to be able to use that information and collect that data from your simulation results or your modeling results as well. So this would allow you to do that. So if I drop this over here, it's going to go out, and if I open the network window here, messages window, you'll see down here, this will give you details, and there's just some output saying, hey, you know, we went out, we found this path, and we were able to match it into the network. So if I go now into our paths and select the new path set, so what this has done then, if I highlight all of these, is went and grabbed all those KPIs that we had in the website, brought in the geometry, then matched them into the actual Zoom network. So you can see here, you know, all the link numbers. So we now have all that information. It can pull travel time information. In this case, we're having to pull travel time and max travel time. You could also do, you know, individual time periods if you wanted. So the next kind of script we have is we can take and actually get some more detailed information about one of these KPIs. So if I drag, I have a heat map script here. If I drop that into Zoom, it's going to open, give me this little dialog box here. I can hit paths. And if I select, let's find one here. Let's use it one. Which one is it? There we go. So we'll do this one. If I bring up that dialog box and hit run, that's going to go out and get the last 24 hours, just like we saw within the Flows interface itself, and generate that kind of time profile and heat map directly within the modeling software. So you could do the exact same thing except for the historical data as well, or pull some kind of aggregations. So across these paths, if you wanted to see what the average travel time and unusual travel time over, you know, every weekday for the last, you know, however many months, you could certainly do that. So again, that's there, both the Zoom version file and these scripts. So, you know, you can take inspiration from that in terms of, you know, how you can use this to pull this information directly from Flows into your modeling software. So I think with that, we're going to pause just for a minute and go ahead and go through the poll questions while we get ready for the next segment.
All right, for our first poll question, how did you hear about our webinar on PTV Flows? LinkedIn, digital advertisement, word of mouth, or in-person event, or email or newsletter? Perfect, and we're gonna give a couple more seconds and then back to the presentation. Thank you, everyone who has participated.
All right, thank you, Tiffany. With that concludes the information that we've prepared for today's webinar. So right now we're going to go ahead and open it up to Q&A. So if you do have questions, you can enter them in the GoToMeeting questions box, and we'll do our best to go through and answer as many as possible.
All right, thanks, Adam. So we have a few questions here. The first one is, what are the penetration rates for TomTom?
Yeah, thanks. Great question. It's going to vary a little bit depending on both the geographic location and the type of facility. So interstates, in my experience, from what I've looked at, have been a bit higher. But we've seen penetration rates as high as 30%. But pretty much everywhere we've been able to do a direct comparison between the penetration rate with some kind of collected count data. It's been really good, and certainly large enough sample sizes to come up with some good data. And it's worth noting too, because I've had a few instances where I've noticed that roadways have been shut down, for instance, and the system will actually, and you can actually see it on the screen here, gray out some areas if for whatever reason at the current time period there's not a sufficient sample size to produce good data. You're going to know that, so it won't feed you junk, basically.
Great. Next question is, what is the updated time horizon of the data feed?
So by default, we're getting updates from TomTom every 5 minutes. So that's the standard update. We do now offer the option to do a minute-by-minute update as well. There is some additional cost to that just due to the data processing and transfer and stuff like that. But so by default, 5 minutes, you have the option to do 1 minute updates as well.
Perfect. Next question is, how is the flows study area defined? Is it just one large area, or can it be fine-tuned along specific corridors? And once it's defined, can additional roads be added?
So you can define multiple areas. Without going through the whole exercise, I can kind of show you. This DC one's a pretty good example, because you see it doesn't actually show you here, but you can kind of do like polygons within polygons and define more detailed sections. So if I turn that off, so you just see the background map, you notice out here to the west, we're really only getting pretty major roadways, just because I had only the certain functional classification selected. But closer into DC, it gets a bit more detailed, and you get some of these other bridges and more detailed information. And that's because in the underlying system, I drew multiple polygons and selected different functional classifications. So you can, fine tune that. We're pretty confident we can get you the exact coverage that you want, with a little bit of massaging. In terms of updating, at the current, there is some, it is possible to update it on the fly, but it's not as easy as it will be eventually. So we do have the option, you can update it periodically, but it's not super simple that you want to move it around every day or something like that.
All right, and what's the source of the base network, specifically the geometry?
So that's coming from TomTom in their mapping as well. We saw some in the API there that there's some LR codes you can get, open LR codes. You can actually then additionally buy a license to use that map in other data. I mean, for example, like for this, if we wanted to get the map data into another format, whether GIS or maybe a Vzoom network, for example, we could sell you a license to that as well and deliver you a Vzoom file that had all the underlying map data. From what I showed you within the API, you can also pull the WKT geometry of any of those KPIs. So that's basically simplified text representation of geometries. So there's a couple different options there as well.
All right, cool. Can Flows incorporate dynamic TSP logic into its predictions? And if so, how does it balance transit priority against general traffic performance in congested downtown networks?
In this particular case, we're not taking into account transit really. What you could, I guess, in theory do is utilize this information to help generate, for example, maybe you could turn TSP on or off for some different level of priority based on the congestion along the corridor. So, maybe as it got more congested, maybe you would want to, either turn on TSP or for example, in a kind of like EOS controller, there's multiple levels of TSP you can do. So maybe you want to, raise the priority up to a higher level to really prioritize those buses. So in this case, at this time, this doesn't directly take into account transit or TSP.
What you're mentioning is the integration with Centrex Mobility may help with some control over those levers. Sorry, I wasn't sure if it was just me, but you went out for about 2 seconds there. So I don't know if you mentioned. I think you're referring to that, correct?
Well, I was just kind of more referring to just general like TSP strategies. So you could use either the detailed roadway information or travel time information to, in theory, turn some levers around TSP, but there's not a direct feature for that, I guess, at this point, but it certainly would be possible.
All right, great. Can you filter out the data by vehicle type?
Currently in this platform, no. The underlying data, or like for example, we could also sell historical data from TomTom. In that case, you can separate like truck traffic out, but within Flows, we're not providing a separate speed or anything like that for trucks versus regular cars.
Okay, and then for the predictions, are they purely machine learning based, and is there any modeling or simulation required?
So good news, bad news. Bad news is within Flows, or depending, I guess, on your perspective, there is no simulation taking place. All the prediction within Flows is purely machine learning based. On the other hand, we do have a more advanced system called Optima, and that's exactly what Optima does. So we still have a built-in connection with, for example, TomTom data, so you can pull that information directly in without doing as much integration. But under there, you have the option of also integrating a traffic model, and you can do kind of a large-scale kind of mesoscopic simulation of the entire region. It runs very fast. You can do scenario comparisons, things like that. But we also have Optima Micro, which actually integrates and embeds a VSIM model in there as well. So maybe you want to look at things like different, traffic signal timings, things like that. So you can do that and actually get predictions that are based on a simulation, either that kind of meso or micro level. So if that's kind of the direction you want to go, we do have Optima that fulfills that. But in Flows, this is meant to be a really quick to deploy, kind of turnkey system. So this is all based on machine learning.
All right, great. And probably related to what you just answered, question is, many of our traffic models in our city are already developed in VSIM and competitor to remain blank by me. Could PTV Flows build upon these existing models and feed them into Flows for real-time use rather than starting from scratch?
Yeah, I mean, if the question is, could you pull this information and do real-time simulation, that kind of goes back to my answer to the last question. Whereas with Optima Micro, which is the VSIM-based system, you can do that. That takes the real-time traffic state and updates the VSIM simulation and runs a simulation based on the real-time data. On the other end of the spectrum, you can take all this information, use it as a great calibration tool as well, kind of like we showed in the VZoom example, where you can pull that information directly from this platform into VZoom for use. And you could do, some kind of real-time operation with that. We have seen a few people, not with Flows, but do kind of similar stuff for looking at rerouting. But again, for the real-time piece, that's where really Optima is going to take over from Flows. So you have all the same data, even the same machine learning capability there, but you can also layer on the modeling and simulation piece, and really much more of a robust like decision support system.
Perfect. For the historical data, how far back is it available, and how long is it available for use into the future?
So we offer a couple of different solutions here. So you can buy this version of Flows, depending on the use case. If it's only real-time based, you could have it so we weren't collecting historical information. We're still collecting the average for that day a week hour of the day, and then 95th percentile, things like that. But we're not like logging all the historical data. So that's option number one. If for whatever reason your use case doesn't require historical data, we can keep it very simple. If you do want historical data, we offer that, and kind of you get to choose how long you need to store that. So, you know, if you want to say, I want 5 years worth of data, we could certainly do that. And so that's basically how long it's going to persist, is, you know, how long you look to store that data. And then, you know, the only caveat being, you know, if at some point you want to discontinue the use of flows, which, you know, you wouldn't no longer have access to that data. But yeah, so basically, as long as you're willing to pay for the cloud storage, you know, you certainly can do that.
All right, fabulous. Okay, you mentioned something about flows being multi-jurisdictional. Can you elaborate on that?
Yeah, so actually what I have on my screen is a great use case of that. So within here, we have data being collected from multiple jurisdictions from a state perspective. So all this over here is Virginia, you know, all this over here is Maryland, and we have DC here. And, you know, within those states, then, you know, we have the Arlington County, City of Falls Church, City of Fairfax, City of Alexandria down here. So all that to say, basically, you know, you can monitor areas outside of your control. I always use, as a matter of fact, here for the City of Fairfax is a good example of that, because, you know, here in the City of Fairfax, a lot of this traffic that goes through the city, this is outside of this particular polygon here, a lot of that traffic is going to heavily rely on what's going on the toll road and what's going on 66 and the Beltway and how people divert. So you could begin to monitor that outside of your particular jurisdiction. Or maybe, as I mentioned, you know, maybe you are the MPO for that region and you need some way of, you know, collecting this information or viewing it in real time, holistically at the region-wide level. That's what Flows gives you, because you don't have to worry about, you know, installing detection on roadways outside of your control and dealing with communications, things like that. So those are your kind of your options there. So that's what I kind of mean by multi-jurisdiction.